My name is Jim Trudeau. I'm a Senior Applications Engineer at Cypress, and today we're going to be talking about the Peripheral Driver Library, the PDL. The Peripheral Driver Library is a body of code that's designed to help you build peripheral drivers for FM parts. It supports FM4, FM3, and FM0+. So let's talk about how to get it, and then we'll go through a tour in a high-level architecture of how the PDL works and what you might be able to do with it. So let's go to the Cypress website and take a look at where you find the PDL. So on the Cypress homepage, there's a products button, and you click products, and a list of products appears, one of which is the FM4 32-bit ARM Cortex. So we'll click that to go there, because the PDL is fundamental to developing software for all the FM parts. On the FM4 page, there's a link right at the top that says, Learn about the Peripheral Driver Library. And when you click the link, you go to the PDL product page. This is where you can get all the information you need about the PDL. It is essentially the gateway to everything PDL. So there's a description near the top. There's even a download button. And as you scroll down, you'll find there's a lot of related links for a lot of the technical information that you need to use the PDL. And there's a list of all the supported peripherals that work across all of the FM portfolios. And there's some links to supported development tools and a lot of related files that you might need. So this is where you go to get the PDL. Now let's take a quick tour of what you get once you download and install it. Okay, so I've got the PDL installed on my machine. We're looking at PDL 2.1. You can install it wherever you want, but I've installed it in the default location. And this is what you see if you open up the PDL. There's a collection of folders. So the SimSys folder has a collection of header files that are required for SimSys support. We'll talk about the devices folder in a minute because that's fundamental to what you want to do. The doc folder, by coincidence, has all the documentation. This is where you would find the PDL API reference manual. This is everything you need to know about the PDL and how it works. The drivers folder is where the actual PDL source code is. So for each driver, there's a folder, for example, the analog to digital converter, which is at the top, and inside that is the source code. Typically, you never need to touch these files. In fact, you shouldn't. This is the code that implements the peripheral driver library on the FM parts. Let's go to the examples folder. The examples folder is a collection of code examples that are designed for particular starter kits that are available from Cypress. I've got two on my desk. We have the S6E2GM, which has an FM4 part, and we have the S6E1B8, which has an FM0+ part. These are two entirely different processors, and the PDL works for both of them. We're going to be using both of these in other videos in this series when we talk about how to really get work done using the PDL. So in the examples folder, you see that there is one for the S6E1B8, and a folder for the S6E2GM. Let's go inside the FM4 one, the S6E2GM, and you note that for each of the peripherals, there's a code example. So let's go look at one. In fact, for this peripheral, there are three. There's one that uses DMA. There's another one that uses multi-channel polling because the peripheral is capable of scanning up to 32 sensors at once. And then there's one for one-channel polling. If you look inside each of these folders, you'll see pretty much the same thing. There's a main.c file that actually implements the code example. There's a PDL user.h file, and we will talk about that in detail, what that means, how it works, and how you use it. And then there's a collection of folders for each of the popular IDEs. So we have IAR Embedded Studio, we have the Keil MDK tools, we have iSystems Win IDE, we have Atollic True Studio, and we have support for ARM GCC command line tools. So let's look inside one of these. Let's pick IAR. And inside here, there is the project file that's required to run, and this is configured to work for this board and will work right out of the box. Just double click and it works. So if you double click the project file for any of the IDEs, it will open up in that IDE ready to go. You can just build, download, and run. For now, let's just close the tools and go back up to the PDL folder. The last place I want to take you is the Devices folder. The Devices folder for FM0 Plus and FM4, in each one of these, for each portfolio, all of the configuration and startup files that you need to program for any device in these portfolios is here for you to use. So what we've covered here is some of the key features of the PDL. The PDL is provided as source code, so you can see exactly how it works and debug down into the library if you need to. The PDL handles all of the low-level programming details. You don't need to know what register and what bit in what register runs what feature of the peripheral or the driver. It handles all that for you. That means the PDL gives you the ability to easily configure your driver to work exactly the way that you want. The PDL is in fact a hardware abstraction layer. It supports FM0, FM3, and FM4. You write the same source code and it works on all of those parts. And finally, because you have the source code, the PDL is an excellent learning tool. If you want to work close to the metal, you can walk into the PDL code and see precisely how it manipulates the processor at the register and the bit level. And that's pretty cool. So you get source code for every FM peripheral. You get portability, a hardware-independent API. You get code examples for low-cost starter kits so you can see how each of the peripherals work. You get all the startup code and configuration files for the FM4 and the FM0 Plus parts. FM3 is coming. And you get support for the most popular IDEs. Programming a microcontroller isn't all that easy, but the PDL sure makes it easier. Thanks for watching.